Hello, this is a short video showing how to integrate the GJD range of IP devices into Control4. You should start by copying the supplied drivers to the normal location, the Control4 drivers directory on your hard drive. Then when you run up Composer, you will be able to search for those drivers. So if I type in GJD, and the drivers appear there. Now you will notice there are individual drivers for each of their products: IPA, IP adapter, DTect, which is the PIR motion sensor, and the Clarius, which is the illuminator. In addition, there is a fourth driver, which is the notification service. Now you need one instance of this notification service in your project, and all devices then send notifications to that driver, and then this driver is responsible for handing them on to each of the individual product drivers. Over here you will notice I've already added a notification service, and it is sat there waiting for a notification. What we will do now is we will add in one DTect device into our project. Having added the device, there are a number of properties we need to fill in. The first one is the IP address of the device, which I will set there. And then there is the username and password of the device. Now, if you notice, the operational mode changed to OK. What happened during that time was the driver was automatically configuring the device with the relevant properties to generate the necessary notifications. This is one of the key points about the driver. There is no configuration needed on the GJD device itself. All configuration is handled automatically by the driver according to the properties that you have set. Here we can see where we set the high and low temperature limits for generating alerts, any hysteresis we want on the temperature, light level limits, and whether the PIR activation occurs always or whether it's dependent on the light levels. The next step we need to do is to check the connections on the device. If you go onto the Connections tab, select the device, you'll notice there is one connection for connecting the driver to the notification service. We need to make sure that is bound, and then the DTect provides 3 additional control interfaces. One is for the PIR sensor, and there are 2 relay outputs. So in the usual way, we need to hook these up to GUI elements so that Control4 has access to them. If we go back to our design view and we want to add in one motion sensor, we add that into our project, and then there are 2 relays. I'm going to add just one of them, and let's say it operates a driveway gate. Now go back onto connections. PIR is connected up to the motion sensor, and digital output 1 is connected to the relay. So now let's go and have a look at the programming and what options are available. On the device itself, you will notice there are 2 variables, one for temperature and one for light level. You can put whatever programming you want to, so you can build in some logic, so when the temperature changes, if the temperature is greater than a certain level, so if the temperature is greater than 30 degrees, then you can do some logic, else if it's less than 20 degrees, to do something else. Now this is in addition to the events that are generated. So here, if we select the DTect, there are a number of built-in events. Tamper, high and low temperature, low light detection, and when low light detection ends. All these are parameterized as per the properties in the driver that we looked at earlier. In addition, the DTect has a number of device-specific commands that are available for resetting the tamper and for initiating a walk test by switching that on and off. Let's now take a quick look at the two other devices, the Clarius and the IPA. So here we see the Clarius brought into the project. Similar configuration for IP, username and password, and properties for configuring the notifications that you will receive. On connections, the Clarius has one digital input and one digital output, and these would be hooked up to the Control4 proxy elements in much the same way as we did for the DTect. From a programming point of view, the Clarius has temperature and light level available variables for you to do programming on, and a similar set of events that are generated. Clarius is a visible or IR illuminator, and it has a number of device-specific commands associated with control of that light, whether you are putting it into standard mode, switching it on and off, controlling the power boost, energy save, or strobe effect. IPA stands for IP adapter, and it's a product that provides multiple I/O interfaces, allowing you to bring various sensors onto an IP network. So if we have a look at connections, you can see it's got 4 digital inputs and 3 digital outputs. It also has an analog input. This isn't available as a Control4 proxy element, but by programming it here, setting its high and low limits, then events when those limits are exceeded are available. Well, that's all for now. Thank you very much for watching, and if you have any further questions, please do not hesitate to get in touch with us. Contact details are now showing on the screen. Hello, and welcome to this short video showing you how to integrate the GJD range of IP security devices into a Crestron project. GJD make a very nice range of PoE powered IP security products. These consist of the DTect range of motion sensors, the Clarius range of infrared and visible light illuminators, and the IPA, which is an I/O controller that can integrate multiple inputs and relay outputs into your project. Now let's open simple windows and take a look at how we integrate the GJD devices into your project. The zip file that you have received contains a sample project already, set up with one of each type of the supported devices, the DTect, the Clarius and the IPA. So here we have opened up the project and you can see the drivers instantiated. We are just going to go through these one at a time. First one we want to look at is the comms driver. This creates a TCP server that the GJD devices send notifications to. This driver is very straightforward. It just has a port number that you can configure, and this is the port of the server that is created within the Crestron processor. There is a single string output from the comms module, and whenever the module receives a notification from any one of the devices, that received data is sent out on the string to all of the attached modules. So here you can see that signal is routed to all instances of the devices that we have got in this project. Each device module makes a decision as to whether that notification is intended for it, and if it is, then it processes it accordingly. If not, it just simply ignores it. So now we're going to take a look at each of the device types in turn. Let's start with the DTect. If you recall, this is a PoE powered motion sensor. First off, we need to configure the module as to which device to talk to, and that is done via specifying the IP address here and the username and password for access. The IP address is used for when we are controlling the device, but also it's used to match up the notifications that come via this HTTP RX signal. If you recall, notifications from all devices are broadcast to all modules in the project, and this notification includes the IP address of the originating device. Consequently, each module knows which IP address it is controlling and can just filter out which notifications are for it and ignore all others. One really nice thing about the module is that it automatically configures the DTect device, so there is no configuration required on the DTect device itself. All the events are configured by the module. In order to achieve that, we need to give the module a few parameters, and you can see these available here. These specify the upper and lower temperatures for raising temperature alarms. It also specifies the lux level at which the low light alarm is generated, and then there is the setting that determines whether the PIR alarm is activated always or whether it is above or below the certain light limit, and the light limit is specified there. Looking at the signals then on this module, that we have the feedback that indicates when the PIR has actually been triggered. The feedback for the actual temperature value and whether we are above and below the limits. Likewise for light level, the actual light level in lux, and digital for whether we're above those limits. Tamper relay outputs, we have the state of the relay indicated here, and then we have signals here for triggering that relay to switch on and off. And we can also trigger the walk test, switching that on and off with feedback as to what state we're currently in. If the tamper's been triggered, we have a signal here for resetting that. There is also a signal here to force reconfiguration of the alarms. You shouldn't normally need to use this, as the module will automatically configure the device when the process starts up. The Clarius is a PoE-powered IR and visible light illuminator, and it is set up to a very similar manner to the DTect unit. If we look at the properties, we've got IP address, username and password as we'd expect, and then our parameters for upper and lower temperatures for raising the alarms and light level. Now, looking at the signals on the module, you can see a number of signals related to the controlling the LEDs. These consist of analog signals for setting power and timeout values, and then digitals, which you have to pulse to switch the LEDs on and off in the various modes. The important thing to note is that the analog values do not trigger an update on the device. They are for setting a value, and then the device is updated when you pulse the digital on or off. We also have feedbacks as to what state the LEDs are in. The Clarius has a single relay output which we can control on and off by pulsing these digital inputs, and we show the associated states. It also has a single digital input, and the state of that input is reflected by this digital output signal. Like the DTect, we have the tamper feedback and signal for resetting the tamper if it's been triggered. we have the feedback of the light level in lux, and a digital indicating whether the low light level alarm has been triggered or not, and likewise for temperature alarms we have a string value representing temperature and digitals for upper and lower temperature alarms. So now let's have a look at the IPA. If we look at the properties in that, we've got the IPA address, username and password as we expect. This device has 4 digital inputs, 1 analog input and 3 relay outputs. On the digital inputs, as well as detecting a high or low level, we can also detect our frequencies and we can set alarms for high and low frequency alerts. We need to configure these in the parameters, and here you see the configuration for upper and lower frequencies for the 4 digital inputs. Also, we need to configure the upper and lower limits for the analog input, and likewise for the temperature measurement. If you then look at the signals at the top, here we see the signals relating to the 3 relays. We can switch them on and off individually, and we get feedback as to what state they are in. For the digital inputs, we have feedback as to whether they are detecting a high or low signal, and also if there is a frequency alarm being detected, and this is replicated for the 4 inputs. Likewise, for the analog input, there are alerts for upper and lower limits being exceeded, and also a string output indicating what the current value of the analog output is. The temperature, we have string output of the current temperature together with digitals that indicate whether the upper or lower levels have been exceeded. We haven't provided a touch panel design for these modules, as they are most effectively evaluated in Simple Debugger. Simply run the project in Simple Debugger, then you have full access to controlling the signals and monitoring the various events that are being received. Thank you very much for looking at this video. If you have any further questions, contact details are now showing on the screen. Hello, and welcome to this short video showing you how to integrate the GJD range of IP security devices into your RTI project. GJD make a very nice range of PoE powered IP security products. These consist of the DTect range of motion sensors, the Clarius range of infrared and visible light illuminators, and the IPA, which is an I/O controller that can integrate multiple inputs and relay outputs into your project. So let's take a look at how we integrate this into your RTI project. The first thing you need to do is to bring the driver into your project. Now there's just a single driver that covers the entire range of DTect, Clarius and IP devices, and when you bring it into your project, you then configure it with the number of devices of each of the types that you are going to support. So here we have a project that is configured with just a single DTect device, and here you can see the properties for configuring that device. We will look at those in a moment. If, say, we had a project with 3 DTect devices and 1 Clarius, then what's happened, we've got configuration parameters now for each of the individual devices. So let's now look at the configuration for the DTect first off. There are a number of parameters here you need to configure. The name is an installer editable field, and the reason for having this is it just makes it easier to refer to RTI system variables and functions with the right name for your detector. So let's say this was a front door motion sensor. You need to configure the IP address and username and password to access the device. In addition, there are certain parameters that you need to consider in order to tell the DTect what sort of events to send out. There's no configuration required on the DTect device. All the configuration is done automatically by the RTI driver. So there are just a few parameters you need to fill in: high and low temperature alerts and hysteresis value. So what this means is if the temperature exceeds 35 and raises an alarm, then these two actually drop 5 degrees below that before it will go into the non-alarm state. This is just to prevent multiple triggers if the temperature is hovering around that 35 degrees mark. In addition, for the DTect, there's a low light level value and the light level in lux, which the low light alarm is triggered, and then a configuration that says when motion sensor is activated, whether it's always activated or only when the light level is below that value or above that value. After having configured the DTect, we can now look at what variables and functions are available for that. So with the DTect here, you can see we pulled in the name, we've got front door here and all the system variables that are available. So we've got PIR detection, low light, tamper, temperature value, high and low temperature flags. We've got light level and the current state of the two relay outputs on the device. In terms of the driver commands that are available, there are two relay outputs on the unit, and we can open, close and toggle the state of those. We can also put the unit into a walk test mode, and if there has been a tamper alarm, we can actually reset it. So we now also need to look at the events that the driver generates for the DTect device. So here we can see the events for the DTect device. We've got the PIR being activated, the low light level being detected, the high and low temperature alarms, and the tamper. And we can simply add the event. So if we want something to happen when the PIR is activated, we can trigger that system macro. Now we've provided a virtual panel interface that is useful just for testing the functionality of the DTect. And this is already wired up to the various system variables, indicating the status of PIR detection, low light, temperature alerts and so on, and also being able to control the relay inputs. Now let's have a look at the Clarius. Again, it's configured in a very similar way. There's the IP address, username and password. We can give it a friendly name, and again high and low temperature limits, hysteresis and low light level. It's very similar to the DTect. System variable wise, again it is very similar. There's only one relay output on the Clarius, but also there is one digital input. Looking at the system functions, we've got the control of the relay output, open, close and toggle, similar to the DTect. We then have a number of functions for controlling the state of the illuminator. So we can put the LED illuminator into a standard mode, switching it on and off, setting the power. We can put it onto a boost mode with a timeout measured in seconds, or into energy save. Or if we want to, we can actually put it into a strobe state. So let's now look at the events that are generated for the Clarius. Here we see the Clarius events, and again here we've got low light, high, low temperature alarms, but we've also got events for when the digital input goes into a high state and a low state, and also the tamper state. So let's say we have a digital input and something wired to the digital input. We want to generate an event when that goes low. Simply select that event and select the macro that we want. If we have a look at our virtual test panel for our Clarius device, you can see we brought in the system variables for low light detection, tamper, temperature, state of the input, and output, temperature display, light level, and also control of the relay output and all of the functions for control of the illumination. This panel should be fully working in this example, so you are ready to go and evaluate with it. Finally, let's go and look at the configuration of the IPA. Now this is a very flexible product that has 4 digital inputs, an analog input, and several relay outputs. Each digital input, as well as detecting high and low states, can also detect frequency of the incoming signal. So in the configuration we have values for high and low limits on that input frequency. So that is true for 4 digital inputs. Then we also have an analog input, and we have high and low values for that together with a hysteresis value. There's also IP address, username and password, the typical configuration that we need. Now remember, there's no configuration required on the IPA. The driver takes all the parameters and then configures the IPA to generate all the necessary events, making your life very simple. Looking at the state of the variables, it's very much as you would expect. Variables for temperature, high and low, the current state of the outputs, the current state of the inputs, and whether there has been a frequency alert on each of those inputs. And likewise current value for the analog input and high and low alerts. In terms of system functions for the IPA, there is control of the 3 relay outputs, open, close and toggle, and the ability to reset the tamper. There are quite a few events the IPA generates, and you can see them all listed here. We've got the high-low temperature alarms, and then for each of the digital inputs, as we have mentioned, you get events when those signals go high and low, or there is a frequency coming in, then it will detect whether or not there has been a frequency alert according to the parameters we have configured earlier. But this is replicated for all the 4 inputs, and then for the analog input we've got high and low alarms. Then taking a final look at the virtual panel, here you can see for the IPA we have the system variables visualized here and control of the 3 relay outputs. Thank you very much for watching. If you have any further questions, contact information for GJD and Janus are now on your screen.